Now we are going to see how to calculate inferential statistics. We will start with t-test. T-test. And we have two modes of t-test. The first one is independent t-test, and another one is dependent t-test, or two sample t-tests and paired t-test. Okay, let's first start with independent t-test. We need a chunk here. We can call int t-test. The formula is just t dot t-test is here, and when you open, you start with your responsive variable or dependent variable. Let's start with our mean pre. Our mean pre. Comma. We don't actually use comma, we use tilde sign. When you hit shift and the left button under the escape button, you get this sign. Tilde shows the relationship between our output and input variable, and then we put our predictor variable or the independent variable. Let's just use gender, and after we put our data, which is marked data. Okay, if we run this code, get here independent t-test. When you open, it's difficult to interpret. We can go back and just print the results. Print our int t-test. When you run this, you can get the results down here. A two sample t-test. We have a t-statistics, we have degrees of freedom, we have p-value, which is 0.007. So it means it is smaller than 0.05, a threshold. And we have confidence interval, -12 until -1. So what does this mean? It means there is a statistically significant difference between female and male student in pretest. Okay, and what does that show? It is shown by this value of p-value, which is less than a threshold of 0.05. Another showcase is the confidence interval. When this interval doesn't include the 0, then there is a statistically significant difference between those two groups. Now, note that independent t-test is used when we are measuring statistical difference between only two independent variables. So our independent variable gender, our predictor variable, gender has only two variables, which are male student and female student. If we have more than two independent variable into our predictor variable, then it is not possible to use independent t-test. An example is let's look into our marked data. See what I was talking about? Gender has only M and F here, but school name, we have school A, school B, school C, school E, school F, like more than two. So let's try and see. If we replace this gender variable with school name variable, if we run this code, then it can't perform it because it is saying grouping factor must have exactly two levels. So it means in a school name variable, we have many levels, but in a gender variable, you have only two levels, male and female. Okay, that's how we compute um, independent t-test. Let's try to see grade. Grade, if you run this, then and print it, we can see the p-value is 0.9, so it is higher than 0.05, our level of significance. And if you see also confidence interval, this interval includes 0 because it starts from -5 through 0 and then to 5. So, and you can see from the mean, from MPG and mean of PCB, it's close, 37.5, 37.3. Then there is no statistical significant difference between levels of grade variable. All right. We can also see accommodation. Accommodation, we run this and print the result. We can see, yes, we have a good p-value and we have a positive confidence interval that excludes 0. So there is a statistical significant difference between boarding school and the day school in favor of which, in favor of boarding that has a high mean. So remember that we are still in a pre-test. So let's see in the post-test. If you replace that and you run this code, print the result, you can see, wow, p-value has significantly reduced, and you see the mean has a big range. A very high statistical significant difference after intervention. All right. So let's say, let's use only the mean. Remember the mean, you have calculated it from post to pre-test. It's a difference. If we run this code and print the results, then we can see there is no statistical significance. Because maybe if you go number by number, because we have taken a difference of post-test from pre-test, and since both were statistically significant, that's why maybe we are not getting a statistically significant difference. And that's why maybe using a difference of pre and post test in the t-test is not appropriate, and you can wait to use a repeated measures ANOVA. All right, and now we can proceed and perform paired t-test. We need a chunk here. You can call a pair t-test. And the same formula but more complicated. The function is just t-test. And we need to go through our data. It's marked data, specify the column using a dollar sign. Let's start with pretest. For a paired t-test, we don't need a difference because we calculate itself, mean, pre, then use a square bracket to specify the predictor. So these are output, or dependent variable, and then here we are going to specify predictor variable or independent variable into square bracket. We start with that data, market the data, specify the column. Let's start with our gender variable. Then this gender, since it is paired, and the gender has two levels. It is paired, it means we have to go with only one level among levels of gender. That's why we use double equal and the quotation mark. We quote that level. Let's start with maybe F to specify female. After that, we need to start another line of code. We need a data specify outcome column. This case is the mean post. Open square bracket our data and specify our independent variable. This case is gender. So we need to specify that the level, we need to use same level, which is F. All right. After that, we need to specify the paired if it is true or false. Then it is true. We are pairing female student from pretest to female student from post-test. It's true. So if we run this code, we can get it here, but it shows bad view. That's why we needed to print it. Print pair t-test. All right. Run it, and here we see a p-value of 0.2. There is no statistically significant difference between pretest score and post-test score of female student. And our confidence interval also shows that because -8 to 2 includes 0. All right. So now let me explain why true. Let's try to put false. Okay. It means you are not pairing F and F. If you run this code and print it, we can see a little bit different results because it doesn't mind to combine the F. So it loses the meaning. Let's just change here for more clarification and put another level different to the level of pretest. In post-test, we put another level, which is male. Now, use false and print. It generates different results, which doesn't make sense. So another meaning here, if we put true and run this code, then we get error because it is true when this level and this level are the same. All right. So let's come back here and now put M and here M. So we're going to see the difference between before and after intervention. So we don't have a statistical significance. So it means many students didn't improve their learning. All right, now see the importance of paired t-tests. It can go one by one. The variable of school name that was not possible to perform into independent variable here can be possible because you can just choose only one level. Let's choose only one level, school A, and here school A. If you run this code, print it, and you can see if we take care only on school A, let's see if it has improved from pre to post test. We see here the p-value is higher and the interval difference confidence is including 0. Therefore, the school A didn't perform well. All right. So let's try school B. School B also didn't improve. Let's try school C. Also, school C didn't improve, and so on and so on. So let's try to change another variable. This case, let's go to grade here. And grade, you have two levels. Let's just use PCB here and PCB here. All right, why it doesn't? It says not enough X observation. Remember last time when we changed this column of grade, here it had SC4 and you have replaced SC4 by an empty. maybe it has reserved a space, all right? But let's just check it. How to check? You come and use unique function. Which data? It's mark the data. Which specific column? It's grade. Let's see how grade column is written. As I was predicting, here we have a space before a quotation mark. So if we come and put just a space here and here, I think it will run. Yeah, perfect, it runs. And here we have the results. So there is no statistical significance. During pre and post test with student from PCB combination. All right, let's try another variable, school type. School type. Okay, school type, we have two levels. One is rural, another is urban, but here we need to use only one level because it's paired. All right, if we run it, print the results, we can see that it didn't make a statistical significance. Let's try to see urban student. Okay. Here we have urban student didn't also improve, all right? So this is how you analyze your data. Go through your variables as you want and check if the predictor variables or independent variables are making a statistical significant difference. And in our case, since we had pre and post test, two levels of dependent variables, and you have various variables, so probably most appropriate test would be ANOVA, and ANOVA will be taken a look in the following episode.